time value of money. I'm sure most of you have learned these concepts in your basic courses in corporate finance or financial management. So what I'm going to do here is briefly a recap of those concepts. Simple interest is calculated, you will recall from what you learnt in your high school, as principal into the time period for which your money is invested into the rate of interest divided by 100. And you would have also learnt another formula which is called the compound interest, where the formula goes the amount that you invest, which is your principal, into 1 plus r to the power of n equal to the amount. To put some numbers here, if you had 100 currency units and you invested it at 10% per annum for a period of 2 years, you will get 121 currency units at the end of 2 years. So in other words, the 100 became 110 at the end of the first year, and then it became 121 at the end of the second year. Now that's the principle of compound interest. You didn't probably realize that what you had learned in school is one of the most fundamental concepts in the world of finance, called the time value of money. Let me rewrite that formula for you. P into 1 plus r to the power of n equal to a. And I could rewrite this as P is equal to a upon 1 plus r to the power of n. Now what we're basically saying is, if I had 121 currency units at the end of 2 years and the interest rate was 10% for 2 years, this amount will be equal to 100. Now this is central to the concept of time value of money. I would replace the principal, which is the amount of money you have today, as the present value is equal to the amount you will have at the end of 2 years, which is the future value divided by 1 plus r to the power of n. And this is the fundamental equation for time value of money, or present value into 1 plus r to the power of n is equal to the future value. If you take a 1 period, the future, and it's just for 1 year, the formula would read future value is equal to, I've replaced present value by C naught. That means the amount of cash I have at time 0. And that would be C naught into 1 plus r is equal to future value. Let's complicate this a bit more. How much would an investor have to set aside today in order to have 20,000 currency units 5 years from now, if the current rate is 15%? Now if you just work that through, at the end of 5 years, 20,000, he needs 20,000 divided by 1 plus 0.15 to the power of 5 would give you a value of 9,943 currency units. In other words, what this is saying is, so from present value you can calculate the future value, and from the future value you can calculate the present value. This actually is a case where if you went and put your money in a bank, and every year they are paying you interest at the rate of r, at the first year they would give you a certain interest amount, second year they'd give you an interest amount, and so on and so forth for the n years that you have put the money. And at the end of the nth year, they're going to return the principal back to you. Now if you were to present this in the form of a time value of money equation, the present value is equal to the cash flow in the first year divided by 1 plus r to the power of 1, the cash flow in the second year divided by 1 plus r to the power of 2, and so on and so forth until year n. This is the time value of money equation that forms the basis for bond pricing. The r in the denominator in the bond markets is known as the yield to maturity, and the C1 to Cn is known as the coupon. In the forthcoming video, we will try to understand the meaning of yield to maturity, i.e. an interpretation of this term r, and thereafter we will look at the relationship between coupon and yield to maturity going forward.